I'll start out by preparing the rotor and stator parts that are to be used in the strip assembly. I'll start with the rotor, and if I roll up in the tree here, you'll see that it is, I started with a imported solid body that was open from a step file, and I could use this as it is, but I'm going to recreate some of these holes with patterns so that the patterns can be used to not only create the punches in the strip assembly and in the tool, but also be used for the creation of the holes in the plates in the tool. And that helps performance and ease of the creation. I created a reference sketch just so I knew where all the holes are. Then filled in the holes that were going to be patterned. This hole and this hole I did not fill in because this is a unique hole compared to the other 7, and this hole is just a single hole. So you can see I just used delete faces to remove each of the holes that I will recreate. I create a cut hole right here, then pattern it. Create this circular cut hole and pattern that in 8 places. And I create this circular hole and pattern at 3 places. Then, since all I need is to create the first instance of these holes, I am going, and then they'll be patterned in the strip for the punches. I am going to suppress the patterns so that we just have the first instances of each of the punches. I'll save this and I will run part preparation. First selection will be the die face. Then select the origin of the part, help locate the part in the strip, and click OK. It'll create the strip starting folder. Save the part again and go over to the stator. You can see again it's just an imported solid from a step file. Create that reference sketch. Fill in all of the openings for what's going to get patterned. Create the first cut right here, and I'll pattern that to 48 locations, and I'll create this cut hole right here and pattern that to 12 locations. Again, I need to suppress these patterns so I only have the first instance. Save this and run part preparation. Select my die face and origin point. Strip starting folder is created. Save this part. And now I can create the strip assembly by selecting Create Edit Strip Layout. Tell it where I want to save it, and I'll just save it in the strip folder. I'll give it a file name. I'll call it Strip Assembly. And I'll enter a project name. This would be your quote number, job number, tool number, something unique to this, so that all the all the files of the strip assembly are unique to this job. You can see that was automatically added. So I want it to be feeding left to right, so I'll uncheck this. And I'll go into configuration at station, and here I could add some stations, but I could always add more. Or delete stations also. And I'll select Save to create the strip. And it creates the strip assembly. So what I'm going to do next is add the other part. I'm going to add the rotor. So I select Add a part to the strip. And I'll select the rotor. Again, go into configuration as station. You can see it just defaults to the what I had set for the other part, so that's fine. Actually, I want to change this to no configuration. So now I got both parts in the strip. I just need to center them up on the strip. So I'll select Stator, and I'll make the Y at 0 because the origin of the strip is at the middle of the stock width. And I'm going to come down here and change my progression. I'm going to round that to an even 5.3, and then I'll make the X half of that. And now you can see that with the preview here that the stator is centered going down the middle of the strip. I'll select the rotor. I'll do the same thing. I'll just say in the Y I want that at 0, and at the X I'll just change that to be the same as the rest of it. And you can see both are now centered. I got my progression. I can also change my strip width or adjust the distance from the edges. I'll just change this to something even, a nice even number. Then this distance from the edge will update. And then I'll hit apply, and the changes are made. I can now take and start creating some of the punches. Let's go to the punch tab, and I'll select create all the punches for the inside cuts, and I'll just create it for the rotor at this time. I'll create in station 2 cylindrical and non-cylindrical punches, and click OK. Here you can see those punches are created. The only other punch I need to create is for this one. That one I'll just use add a cutting punch. Select that. Convert that. Exit the sketch. And you can see what it did was it created a part file for the punch, inserted into the strip assembly, and put me into a sketch. I just had to sketch in what I wanted the punch to be. And I just converted entities off the blank sketch to do that. That blank sketch was automatically created by LogoPress. At this time, I can take and slide some of these punches around. I could also pattern these punches. So if I had this punch selected, I could then use the previously created patterns to pattern it. So like for this one, I can say I want to use this pattern. I have them named so I know what they are. You can see it just pattern that punch. I could also select this punch, use that pattern. I can select this punch and select that pattern. And this punch, you can see this punch right here is different from this one. This one will be the only one that gets the pattern. Just like that. And then I could start sliding them around. Say select this punch and move this one over. I can select this punch, slide that over 2 stations, and this punch, I'll also make that over 2 stations. And then when I hit apply, not only will it move the punches, but it'll also make the cuts in the strip. There we can see the cuts and the punches moved. I can create the punch for where we're cutting out the rotor. I'll go add a cutting punch. I'll say I want that in station 6 because it'll be idle here. So let's create that in station 6. And I'll just take this blank sketch entity, right click, select chain, and convert that. There's the shape of the punch. Exit. There's where it's cutting out the rotor. And now I'll create the punch for where we are creating that pattern of punch with this shape going all the way around. So I'll go add a cutting punch again. Select chain, convert it. Of course, I don't want all of this down here. I can always select and delete what I don't want. Gotta get rid of this horizontal relation so I can make that perpendicular to those other lines. And these are just SolidWorks sketch tools I'm using. Exit sketch. And that punch is created, and then that punch is also selected, so I can then say I want to use this pattern for that punch. Next, I'm going to create the cutting punch where it cuts the inside of the stator. So I'll go add a cutting punch again. Come over here, select chain, convert that. Again, I can always delete what I don't need. There's that punch. Exit the sketch. Looks like I need another station here on the end. So I can always select that station, add a station before it. But in this case, I just want stations on the end. So I am going to go to strip and just tell it I want 2 more stations on the end of this. Hit apply. So add the stations is also applying the cuts into the strip for these other punches. These two parts are not needed, so I'll just hide them. So now I need the punch for cutting the outside of the stator. Go to the punch, add a cutting punch. Select the chain and convert that. Exit the sketch. And that punch is created. This red is just a preview of what will get cut away. I'm going to create a couple of cutting punches for pilots. So I'm going to go into add a cutting punch again. These two entities I'll convert as construction geometry, just a dimension 2. Dimension it, exit sketch. Create another punch. Again, convert for construction. Exit the sketch. And I'll apply those cuts. And our strip is completed, so now I can exit out of the strip layout function. And there's a list of things, a list of information it'll calculate and display. Check or uncheck those. Select yes. And here it just created a join strip. So you can see here it's not individual parts anymore. It's just a single part for the entire strip. Looks more realistic. And you can see it created this information note with for progression strip with cutting forces, distance, perimeter around the cutting punches, and so on and so forth. And it also created a strip information note here with that. It's just a spreadsheet with all that information in it. There's our strip. Now we can start creating the tool. Save this. And I'll select tool structure. And And I'll say I don't want that in the strip folder. I want that up one folder. And I'll just call it tool assembly. Again, it already has the project name associated. It already populates the project name for the strip into here. So I don't need to enter that. Now I'll select the tool template. These tool templates can have as much or as little as you want in them. You can see the ones I'm selecting have different things available. So I will select this template. It's very basic, just a die set with a die block in it and a little guide stock tray and guide rails in here. I'll hit save. We'll create the tool assembly according to the template I had selected and then insert the strip into it. And we can adjust things like the position of the strip. If I wanted the strip to be back a little bit further, I could do that. I can also take and adjust, say, the die set, select it, scroll down and change these values. I can always adjust things later. Take and change this a little bit more. Change the width. Okay, I can also use the filters here to show, say I only want to look at the lower half of the tool, hides the upper half. Now I'm going to adjust this rail and tray assembly. Select it from the list. Scroll down, we have some values I can change. Well, the strip is 4.350 wide, and then I can say I want plus, say, 20 thousandths to that. I can also adjust these rails and so forth. Oop, and I make that a little bit wider. I want that to be 5.370. There we go. Can make the tray length a little bit bigger if I wanted to. Make the rails a little bit longer. I can adjust the die block. Then if I want to add another die block here, select add a plate. I want to go into the lower assembly, plate from template, select a plate template from the list here. I can enter a name, or I can just give it a name, pick it from the list, or I can enter it. Select my Z position, my X position. I could adapt dimensions. If I want to come in at the same size as that one, I could do that. There's my die block. I can adjust it. I can say, oh, I want that to be a little bit longer. Make that 24 inches. I also, if I want a gap in between here, I could just add a gap distance right here. That's a gap in between there. Then if I say, oh, I want to slide that in a little bit, I could always select the other block and then just adjust the length of it. And you see the other, since this was mated to that just slid over also. Let's say I want a punch plate on the top. I can do that. I'll just go add a plate. Upper assembly. And this I'll just call a punch retainer plate. Z position right there. X position, I'll just have it come off of this face. And I will adapt dimensions off of that block so it comes in at the same size, or readjust its size to match. And then after it's in here, I can always change something like, say I want the thickness to be just an inch thick. Add another plate, get in the upper, put in another punch retainer plate. X position, or I gotta select my Z position first, then the X position. I can say I want a gap distance of 1/8 inch in between there right away, and I want to adapt the dimensions so it's the same size as that block. Just change the Z thickness to 1 inch thick. Do the same thing. Let's just go add a plate, and I'll add some stripper plates in here. Middle assembly. I'll just call it a stripper plate. Z position, top of the strip. X position, off of here. And again, I'll adapt dimensions. It's just telling me that it's going to create an external reference because I'm mating it to things that are not in the middle assembly. I could say no, and that I don't want to create it, and then I could make changes. and then click again. But I do want to create these external references, so I'll say yes. Add one more plate, stripper plate. Again, the Z will be off the top of the strip. The X I'll make off of this face. An 1/8 inch. And I'll adapt dimensions again from that plate. It's going to create an external reference. Yes, go ahead and do that. So here you can see that the plate came in on top of this plate. That's easy enough to fix. Down here in the plate position, I'll just say change that to be adjacent instead. And I'll save this. I'll put some shims, or not shims, but inserts into these die blocks down below. I can say, let's look at the lower, and I'll hide the strip. Say I want to put a die insert in right here. I can use the LogoPress add an insert for that. I'll select the die block. And then I can say if I wanted the die block to be, or that insert to be a couple of tenths smaller or something like that, I could do that. And give it a name, material, and heat treatment. So if I wanted this to be, say, carbide or something like that, I could do that. And I could also put a shim underneath it right away. And I'll say I want that to be 10,000 smaller than the insert. And I can make that different material and heat treatment. Let's see, I'll just sketch that in. Say I want that to be 4 inches by 4 inches. And I'll put some, I could put chamfers on, say, 3 of the corners or something like that. And then leave one sharp or something like that. Click OK. It'll start create the insert. Here's asking me if I want to edit the sketch for the opening in that die block. I'm going to say yes. And I'll say, well, I don't want chamfers on the opening, so I'll just go use a LogoPress sketch tool called Sketch Fillet Management to turn these chamfers into fillets. Then on the sharp corner, I'll use the mismatch option. Put an undercut there. I'll exit this sketch. It'll continue on and create the opening. And now if I hide the strip, you can see there's the insert and the shim underneath it. And then can mount the punches into this, so we have all the die openings and the openings in the stripper plate and the punch plate. Show the rest of the tool. You see there's no openings in any of the plates right now. So I'll use LogoPress punch mounting. I'll say I want to mount this punch, and this punch. I don't have to select the punches of the pattern. Those will automatically get mounted. I'll say I want those to be whatever material type. Show the rest of the tool again. Then I'll select the punch plate right there. It automatically populates the other plates that it feels needs openings in them. You can see it populated the stripper plate down here and the die plate, which is the insert. And then also it populated the shim and the slug openings in the shim and the die shoe. For each one of these, we can select hole types, enter and clearances. So I can say I want, say, 10 thousandths clearance in stripper, 1.5 die clearance, my land and my taper. And then for each of the plates below the die block, I can say for the shim, I just want to be 30 thousandths larger, and I want the opening in the shoe to be 60 or something like that. And once I select OK, what it's going to do is not only will it create the openings on all the plates, but it'll also place these punches into the upper assembly, derive copies of them into the upper assembly. can see those punches are mounted. If I show just the lower and hide the strip, you can see the openings in the insert and in the shoe. I can also see, if I look at the stripper plate, the openings there, and in the upper you can see the punches are up here also. And the punches in the strip are automatically hidden, the ones that are mounted. So punches like these for the pilots, those I can put those in with standard component library. And I can pick different types of punches here. For this, I can, and this is a purchased item, so say for the head plate, select my head plate, I'll select my die plate, and I'll select my stripper plate. Then I can select, you can see there's a very large supplier list to select from. Let's go with a standard Dayton Versatile inch. You can change your body diameter. Here, it already knows my point diameter. Then for each one of these plates, I can select and change, say, the size of the hole. Also, say for the D0, I want that to be bigger, so I can either just add a little bit if I want it to be, add a couple thousandths if I want to guide, or I can right-click standard drill and just go to the next standard drill size too. You can see the preview. For the die block, I could have standard land and taper, or I can come over here and say I want a die button. Put in my land and taper, or my die clearance. That's overall. A little place cross through. I need a slug opening here. Once I have my parameter set, I just click OK. Puts me into a sketch from the top. You see it has one of the points already placed. I'll just place another one. Just make it to the center of that punch. There's my two punches. You can do the same thing with these punches right here. Let's see if I would just want a headed straight punch, I could do that. Select my head plate, die plate, and you get a preview. I also select my stripper plate right away. Again, I can select different suppliers, add my clearance into my stripper, or I could just add it in, say, a couple thousands if I wanted to guide it. Down here, I can say, again, I want a die button. You can see that the die button isn't long enough, so I can change that and say, well, I want a bigger size. Well, then I would have to choose a say the difference, say a commercial style or something like that. I'll place cross through, need slug hole in here. Click OK. You can see it placed all the points for these because they're all in the same pattern, all the same punch. And I'll put in these as standard components, just like the last ones. If those are all the same, looks like. Select the head plate, die plate, and stripper plate. And get a preview. Got those. I can also add the other points in there right away. Yeah, since they're the same size. I just have to hide these. Can continue on mounting the rest of these punches. So go into these, since these aren't standard components, I'll use punch mounting. want that, that, and that. Do all three of those at once. Select the punch plate. All the other plates are already selected. You can see it remembers the last entered values. So all I have to do is take and click OK. Those punches are mounted. As long as these plates are within the same punch plate, we can mount them all at once. I could have mounted these two at the same time. Check my offsets. Yep, everything looks good. And those are mounted. Hide the tool. You can see all the punches are mounted. If I show the lower, see all the openings. If I look at the middle, and then also the upper. Save that. There's also other standard components such as screws and dowels. Select the head where the head of the screw goes and the tapped. I can adjust things, like if I wanted it to that drill to go through, I could say I want that style tapped hole. If I wanted the head to drop down further, I could do that also, and it automatically updates the length of the screw. Click OK, puts me in a positioning sketch. I use LogoPress automatic pattern. Let's say I want 10 points. Put in the dowels. flip-flop them. Want to offset one, I could do that. I can copy these over to another plate. Just have to select it. If I want to edit it, I hit Standard Component Library if I want to change the size or something, but I just want to copy it to another plate. Just change what plate gets the head of the screw right there. And I'll put in some more dowels, so I'll just take and copy that dowel over. Put in some springs. And here you can see we got round wire, rectangular wire, and nitrogen. I'll select nitrogen. And then there's all the different suppliers here. Get a preview. Again, I could select a different supplier if I wanted to. Say if I wanted Calers. Then you got different diameters with different series. You just type in your stripper travel, or your compression of the spring, I should say. Need a hole in this plate. I can also put in clamping screws if I want. Forgot to show you that it does give you the percentage of compression and the force at that compression. It does list that. So if I wanted a different stroke spring, I could do that. See that updates. Gives you a center of force. Got different style pad retainers. We got sh shoulder bolts, but we also have the spool type pad retainers. Want a little bit shorter one, I could pick that. I could always add more in here if I want. Select it, copy it over to the other plate. If I did not like the type of guide pins that are in here, I can always select it, edit it with standard component library. And I can say, well, I want this to be, let's change the type of it. I want this to be ball bearing demountable. You can see here, it'll change it. Same thing with the bushing. I can say I want that to be demountable. And I want, I didn't want Danley. I say I wanted Superior. When I'm done, I just click OK. Puts me into a sketch. I could change the position if I'd like. Removes the old components and holes and puts in the new components and holes. So if I wanted to, say, put some lifters on the bottom, lifter guides on the bottom, I could do that. That would be more with the standard component library, machining axes. Select the reference face there, and I'll say I want 3/4 diameter or something like that. Might be a little bit big. There we go. And add a component to it. We created some custom components. I'll just say I'll put some TR Jones style ones in there. You can see we got 3 different styles. So I want to put in that style right there. And adjust the diameter and so forth. I could say I want to add a spring underneath that. Add some compression to it, gives you the force. Of course, I want a longer spring than that. screw cap underneath that. Then I want a hole in here. I want that to be a tapped hole, and I pick my size. I also need clearance in the stripper plate. So I'll click there, and I want a pocket like that. I need that to be Of course, if I wasn't sure about that depth, I can always take a measurement. Oh, I can't take a measurement yet, it's not in there. And let's say that's what I want. Well, I can save this out as a favorite. And I'll just call this a lifter guide, or a guide lifter. And then I can also say, okay, this is going to be the top of die block, so it'll tell me what to pick. Continue to put this in, click OK. Make it so these are horizontal. Add a little bit for clearance. It's our lifter guides. And I could put some over here. I'll just go back into machining axes. But this time I'll select a favorite from the list right away. Guide lifter. Select the top of the die block. Select the die shoe. Select the stripper plate. You'll see it remembered everything. Put in relations so that they're in line. Here's our lifters. We can animate the tool at any point. We can animate the tool. You just go into LogoPress 3, die debugger. All we have to do is type in the stroke, stripper travel, and our lift height, strokes per minute, hit play. We can add other things to the animation. Just add a sequence. Then I select what I want to add. Let's click on one of these and hit select all instances. Same thing over here on this instance. So I can animate these lifters. And I'm going to tell these to be linked to the strip in the vertical motion so that when I hit play, now you can see that the lifters are going up and down. Very easy to add other motions to the tool. Once you have your motions set, go to the Interference tab and select Interferences Computation. There's other things you can set down here. Going to ignore hidden components and so forth. And it's going to check for interferences with the tool closed, and then when the strip is progressing, every tenth of progression, I could have changed that tenth of progression to every, it could divide it into 20 or 50 or however many increments of the progression I want to check for interferences. You can see it's checking as it's progressing. Then you can gives you a list of the angles of the press that check for interferences. The ones that have interferences are the ones that have the plus symbol. Expand that, and I can click on one. You can see I didn't clear out the rails. Oh, that must be the screws for the rails. So on. Here I didn't clear out for, I must not have told it to put a hole in the punch retainer plate for the pad retainers. I didn't make the lift is too high for the rail, so I'd have to make the rail hook on the rail a little bit taller. So I didn't. Same thing there. Then I just make notes of what I need to change for the, say for these pad retainers. We do have clearance in this one, but I don't have clearance in this one. So I just need to select this, edit it using standard component library. Other place cross through. I need a hole in that plate. So now you can see we got the preview for the hole. And it'll add those holes. Same thing for these guide rails. I can just go back into tool structure. Select the rail and tray assembly, and then the notch in the Z, I could say, well, I'll just add 50 to it. So it's 300. Now I definitely have enough room. And I could go back into die debugger and run dynamic interference detection again and make sure I caught everything. The bill of materials. Of course, I could add more fasteners, hold in, screw in punches and other plates and so forth, but I'll go into and open up the drawing for the bill of materials. There was one already created because it was associated with the tool template that I chose. Select the drawing view, tell it what style of numbering I'd like to use. I'll say I'm gonna have split numbering, so the lower will start at 1, middle at 100, upper at 200, and the center components will be in its own range at 500, starting at 500. We can choose a different table template if we'd like, but here's the preview according to the template we chose. I'll click OK. And since we had the standard components in its own range, it splits the table into 2 tables. You can see all the purchase items are down here and the manufactured items are up here. All the order numbers are in here. If I'd like to kind of open up a part, say this die block, and open up the drawing for it. You see a drawing was automatically created when we inserted it. Slide this over a little bit. Put in a hole table. LogoPress hole table. Select the origin point. Finds all the holes front and back. Tags them. If I didn't want a full table with the positions here, I could always take and delete it and place a compact table. Just drag this down. There we go. And it also tells you what standard components associated with that hole. LogoPress also has automatic ordnance dimensions, or smart ordnance dimensions. 4 different styles of them. Place all the wire dimensions. Say I want to put in a wire start hole in here. Wire EM start hole. I'll just place a point in here. There's our wire start hole. If I go back to the drawing, it tells me that something has changed. Do you want to update it? Yes. Update the hole table, and there's our wire EM start hole that just added. And there it is. If I want to orient dimension it, it's the same as SolidWorks, so I'll just go add to ordinate. And also in the other direction. You can see that the tables are the title block is automatically being populated with detail number, quantity, material type, so on, size, and everything. We can also force the customer and tool description and so forth. That is done from the bill of materials. All I have to do is click on the bill of materials to edit it, edit and update tables. And at the bottom, I can add custom properties. So for the customer, tool description, tool number, and who it's drawn by. Click OK, and those properties are forced to every part in that assembly. And that means it can be linked to any drawing that it's already done. Go back to the drawing and rebuild it. You can see everything's populated. And it'll be in all the drawings. So as you can see, the tool is not fully complete, but it's just a matter of placing in more components as far as screws and dowels and so forth.